Scientists used to consider Mars a geologically dead planet. It's smaller than Earth and loses internal heat faster. In the past, there was a lot of activity in its depths, and there are many traces of huge volcano eruptions on its surface. The largest volcano in the solar system, Olympus, can be seen from Earth, even with an amateur telescope. But volcano eruptions on Mars stopped a long time ago. The planet's interior cooled and solidified. The internal cooling weakened its magnetic field. The solar wind blew away the atmosphere, and the remaining water froze. But recently, Mars has become more active. Everything changed when astronomers studied thousands of images of the Martian equatorial region. The images were taken between 2006 and 2020 by the NASA Mars Reconnaissance Orbiter. The HiRISE camera took the images at an altitude of 300 kilometers above the Martian surface. The images allow us to distinguish individual objects with a size of up to 1 meter. The study revealed a large number of landslides and debris flows on the slopes of the Martian volcanoes. Scientists have discovered more than 4,500 traces of rocks that have left characteristic patterns in the shape of a Christmas tree, which usually happens after a strong earthquake. The longest trace is more than 2.4 kilometers long, and in total, these traces are around 900 kilometers long. About a third of the traces weren't present on images before 2006, indicating that they formed later. It's clear that only very powerful underground tremors are capable of moving these huge boulders. However, until recently, such tremors weren't found on Mars. What helped scientists find out that Mars woke up? How did the recent samples taken from one crater almost come to life? And why will one of the most harmful gases on Earth be so crucial for Martian colonists? Since 2018, the InSight spacecraft has been monitoring earthquakes using the Seismic Experiment for Interior Structure. It recorded more than 1,300 tremors, and compared to Earth, this is close to nothing. We have seismometers that record from 500,000 to 1 million earthquakes every year. Besides, almost all the vibrations on Mars are very weak, up to 3 points. The strongest one at 4.2 magnitude was recorded in August 2021. And then in May 2022, the Red Planet experienced a magnitude 5 Marsquake. On Earth, this could knock out windows in houses and slightly damage our infrastructure. But it was quite a significant event for Mars. Earthquakes are stronger due to displacement of tectonic plates and volcanic eruptions. Mars isn't that active, but the 5-point tremors show that tectonic processes haven't subsided in its depths. Movement and magma bursts continue. When magma rises, it causes the bending of a single lithospheric plate of Mars, which leads to Marsquakes. But does geological activity on Mars bring us closer to solving the mystery of its habitability? We know this planet as a very harsh and inhospitable world, extremely cold, with terrible radiation and no liquid water. And of course, there's nothing like elephants, tigers, or even mice on its surface. They wouldn't withstand such conditions, and we could easily notice some of them with telescopes or rovers. But we wouldn't notice microorganisms with these tools. Microorganisms are able to survive in extreme conditions on Earth, so there's a possibility they could also exist on Mars, especially in its depths, where it's warmer and there's no fatal radiation. Additionally, the discovery of subsurface lakes on Mars is an exciting finding, as it suggests the possibility of liquid water, which is an important ingredient for life as we know it. In 2018, radar instruments on the Mars Express spacecraft orbiting Mars detected a large underground lake on the planet's southern pole, as well as 3 smaller bodies of water nearby. The lakes span an area of over 75,000 square kilometers. This region is located in the Plain of Australia, a large ice-covered plain. And in 2022, Instruments on the ExoMars orbiter showed there are also giant reserves of frozen or liquid water in the Valles Marineris canyons. They're hidden inside a canyon system running along the equator of the planet. The water in the canyons covers an area the size of the Netherlands. It's located very close to the surface of the planet, within the top 3 feet of soil. On Earth, similar subglacial lakes in Antarctica have been found to contain microbes, fish, and other organisms. This could also be the case on Mars. A small amount of heat is retained beneath the surface of Mars from the planet's interior, but it may not be enough to melt the ice. This means that lakes may be frozen due to a high concentration of salt. If it's 20 or more times saltier than Earth's oceans, even microorganisms would not survive. In order to understand this, scientists are trying to determine the composition of water in the underground lakes. They're also searching for signs of life in dried-up surface water bodies. Once, many lakes and rivers flowed on Mars. The planet was warmer and had an atmosphere. Many different organisms could have lived in such bodies of water, but up until recently, we couldn't find any traces. In September 2022, the Perseverance rover made a shocking discovery. It found organic molecules near ancient water sources. This wasn't the first time that rovers have found organic matter on the red planet, but this discovery is important because it was made in a place of ancient river-lake merger, particularly favorable for life. It's located in the Jezero crater, 45 kilometers in diameter. The delta formed about 3.5 billion years ago and had been accumulating sand, dirt, and salts over time. Perseverance has extracted the largest amount of Martian organic molecules from this mixture to date. On Earth, fossils of ancient organisms are also commonly found in such sedimentary rocks. The Sherlock instrument on the Mars rover Perseverance, which is designed to identify organic and chemical substances, scanned molecules from the Jezero crater. Among other elements, it detected hydrogen atoms linked to carbon atoms. Carbon is crucial for life and may indicate biological activity. It's also important to note that the organic molecules in the Jezero crater sediment are intertwined with sulfates. On Earth, sulfate deposits preserve organic matter and often contain signs of life. However, the molecules in the crater may have formed through natural processes. Scientists will be able to determine their origin more accurately once samples are brought back to Earth, which NASA plans to do in future missions. Meanwhile, scientists have discovered other hints pointing to the possibility of life on Mars. Recently, the Curiosity rover detected an unusually high level of methane on the planet, 21 parts per billion units of volume. So what does this tell us? Methane in higher concentrations is found in the Earth's atmosphere and is formed due to the emissions of living organisms. Researchers are planning to find out if the gas on Mars is also related to the activity of its inhabitants. If the methane had formed a long time ago, it would have already broken down into its component elements. Another possibility may be that the gas is a product of interaction between rock and water. But methane isn't the only gas scientists are curious about. Carbon dioxide, considered harmful on Earth, may soon become invaluable on the red planet. The experimental device MOXIE, the size of a toaster, was brought to Mars on board of Perseverance. Its parts were printed on a 3D printer from a nickel-based heat-resistant alloy. Its composition also includes a lightweight aerogel for heat retention and a thin external gold coating that reflects infrared radiation. Thanks to this, the unique device is able to withstand a temperature of 800 degrees Celsius, at which gas transformation occurs. MOXIE has recently produced pure oxygen from CO2. It works by separating oxygen atoms from the CO2 molecules. The byproduct, carbon monoxide, is released into the atmosphere. The tool is designed to produce up to 10 grams of oxygen per hour. However, after an hour of operation during the first test, the gas output was about 5.4 grams, enough to let an astronaut breathe for about 10 minutes. The device is particularly valuable because it's virtually unlimited in terms of raw materials, as the atmosphere of the red planet is 96% carbon dioxide. Also, MOXIE uses regolith, which covers the entire Mars. After processing, this soil becomes fuel, air to breathe, or, combined with hydrogen, water. NASA and SpaceX CEO Elon Musk closely follows scientists' discoveries on Mars. The head of SpaceX actively prepares for flights and promises that we'll see the first images of astronauts on Mars in 2029. 14 Raptor engines of the Starship spacecraft have already been tested. Meanwhile, NASA has also chosen Starship as the first crewed landing module for the Moon. If everything goes according to plan, astronauts will land on the lunar surface in 2025 or 2027 as part of the Artemis 3 mission. Then by 2040, NASA plans to send a manned spacecraft to Mars, and the Moon will become a base for refueling. But after the flight, the colonists will still have to settle in extremely difficult conditions on Mars, and that's when new discoveries by scientists will come in handy. Most likely, as experts say, the first crew will land near the planet's equator. The canyon, with liquid water in the Valles Marineris, will be the perfect landing spot. Water is necessary for drinking, growing crops, and sustaining household needs. The settlers will also need oxygen, as the air on Mars is composed of a toxic mixture of carbon dioxide, nitrogen, and argon, and MOXIE is getting closer and closer to solving this problem. In addition, Elon Musk plans to refuel rockets directly on Mars for the return trip to Earth. To do this, he wants to build a factory on the red planet to produce methane and liquid oxygen from water ice and atmospheric carbon dioxide. If researchers do find microorganisms in the subglacial lakes, it'll also be a step forward to colonizing the planet. Local microorganisms will be perfectly adapted to the harsh conditions of Mars. By studying them, it'll be easier to find ways to protect against the variety of climatic dangers of the red planet. Do you think there was ever life on Mars? Let us know in the comments, and leave a like if you enjoyed this video. And to stay updated on the latest science news, subscribe to the channel. Thanks for watching.